Okay, a terminating decimal is one that ends. Okay, so I'm going to ask you to write this terminating decimal as a fraction. The first thing I'm going to ask you to do is actually call the name of the fraction. You'll see that this one is in the 10th position. So if it's in the 10th position, that means it's actually 4/10. That's not too bad. Now that's going to reduce and we'll come back to it. But if you look at this one, this is tenths, hundredths, and thousandths. So this one's going to be 324/1000. And then of course we'll come back and reduce it. But here's another thing I want you to think about. Let's use that one again. What you'll notice about this one is it has 1, 2, 3 decimal places. So when you get ready to write it, write your 1, and then you're going to have 1, 2, 3 zeros. And that's another thing that you can see. However many decimal places you have, when you're writing it as a fraction, that's how many zeros you're going to have. Okay, so that's how you start. That's how you actually write it as a fraction. But in your work this week, it's going to ask you to write it as a fraction and make sure it's reduced. Okay, so if you reduce this first one, it's going to reduce by 2. So that's a 2/5. So 2/5 is the same thing as 0.4 or 0.40. Okay, when I reduce this second one, I see that it also reduces by 2. So 2 goes into 3 one time. You could actually divide it out old school if you wanted to. So I get 162. And 2 goes into 1,500 times. Now what I see about that is it's going to reduce again because they're both even. So using my divisibility rules from before the midterm, divide by 2 and I get an 81, and divide by 2 and I get 250. And that's how it would look in reduced form. Now as you might guess, what we'll do next is we'll go from fraction to decimal, so we'll go backwards. Okay. Now, in this first, these two here are difficult. They're the bad guys, but the other two aren't too bad. Now, the main way that we do this, and in fact, the way I always do it, is if you read this, it says 9 divided by 16. So if you went old school and you literally said, how many times will 16 go into 9? That's how you're going to write it. Now, this bottom number here, that's your divisor, so that's what's on the outside of your house. And this number here is your dividend, so that's what's on the inside of your house. And the division is a little tough, but that's how it looks. You'll notice that 9 is a whole number, so since it's a whole number, you're going to put your decimal right there, and then you can put zeros behind it. Now, we have to think about how many times 16 goes into 90. I know that 16 times 5 is 80. And 16 times 6 would be too much. So we're going to say 16 times 5. Now, when you get ready to do these on this quiz this week or on the My Math Lab, you may have some bigger numbers, but when you get on your final exam, I'm going to give you good numbers like this one. They're not going to be nearly as bad as the numbers I'm talking about today. Okay, so 16 goes into 100 6 times. Okay, so 6 times 16 would be 96. Okay, 16 goes into 40 2 times, and that's 32. And 16 goes into 85 times, and that would be finally dividing it out. And so this answer over here would be 0.5625. Okay, so let's look at our second one, the 20. Okay, so we'll say 20 is our divisor, and it goes into 7. We'll just keep putting zeros out there. Okay, so 20 doesn't go into 7, but it goes into 70, and it goes into 73 times because 3 times 2 is 6, so that would be 60. 20 goes into 100 5 times. And I don't need the rest of that on there. So your answer for this one would just be 0.35. Now, there's another way to do it if it's close a multiple or can be written as a multiple of 100. Let me show you this way. Now, this only works when this number is easily turned into 100. And this 20 here is easily turned into 100 because I can multiply it by 5, right? So if I can easily get a common denominator that's a power of 10, that's what I want to do. So if I multiply by 5 on the bottom, I get 100. And if I multiply on the 5 on the top, I get 35. Well, that's 35 divided by 100. So we just talked about that earlier. If you have 35 and you divide it by 100, that means you move your decimal 2 places over. So that would be 0.35. You could also do it that way if this denominator can easily be written as 100. Okay, so what you noticed about these two that I did was they divided evenly, but sometimes they won't. And that's what you see on the far side over there. Okay, let me make sure it saved it for me. And it did. Okay. So let's get those nasty ones. So we're going to say, how many times does 15 go into 11? And at first glance, you don't know that it's bad. Okay, so let's think about 15. I think about 15 like in terms of the clocks that we do, like quarter past and so forth. So I think of it that way. So I know that there are 4 15s in 60. And so if I talked about 120, there'd be 8, so that's too much. So I'm going to try 7. I don't know if it works or not. We're just going to try it. 105. That's good. Okay, so that's how we start this one. Okay, so now how many times does 15 go into 50? Well, it goes 3 times because that's going to give me 45. Okay, so I get a 5 there. 15 goes into 50 3 times. Okay, so I get a 5 there. And then I see something's happening, it's repeating. And so this is going to be what we call a repeating decimal. And so when you get ready to write it, you have your 0 that's out in front, and you have 7 3, and the only part that repeats is the 3. And that would be how you would write it. Now don't write it like this, because the 7's not repeating. You only put the little bar over the term that repeats. So only the 3 repeats, and that's how that one would look. Okay, our other one is 53 over 60. And when it's a number like that, a multiple of 10, it's usually a little bit easier to divide than some of the others. Okay, there's where my decimal goes, and that's how I'd set it up. 60 is my divisor, and 53 is my dividend. Okay, 6 goes into 53 8 times. Okay, so my 8's going to go there because it doesn't go into 53, so it gets the next part, which would be the hundreds category there. Okay, so 8 times 60 would be 480. We can subtract. This would be a 5. Okay, so 60 goes into 500 8 times. That gives me 20. Okay, so 60 goes into 23 times. Okay, so the 8 doesn't repeat, so I see that. And I did something. Let's see, what did I do? I'm going to pause it for just a second. I've got one of my zeros off and I don't want to make an error. Okay, so going ahead and working this one. They are tough. They're the roughest ones. Here's what you're going to do. It's a little procedure. It doesn't take long, but it's just a little troublesome. So I'm going to let R be this value 0.676767 which means we continue out. Now you'll notice here that we have two digits that repeat. 6, 7 repeats. 6, 7, 6, 7, 6, 7. Now over here, only one of those digits repeated. Only the 3 repeated, or only the 3 repeated. But on ours, both of these digits repeated. I want you to notice that that's two digits. So if you think of a 1 or a 10 with two digits, think of it this way, because we're talking about powers of 10. Two digits would be a 1 with 2 zeros. So what you want to do is however many digits repeated, you want to multiply both sides by that power of 10. So I'm going to multiply this side by 100, and I'm going to multiply this side by 100. So this would be 100R. Now remember, when I multiplied by 100, that moves my decimal 2 places to the right. So 100R would be 67.676767, ... But remember, we started this green problem with R equaling the decimal 676767. So what we can do is subtract these two. So 100 minus 1 would give me 99R. And over here, the 0.67, all that back part, that scratches out, and that gives me 67. I can divide both sides by 99, and my R equals 67 over 99, and that's what the decimal would look like. Okay, now let's try the one on the other side. Okay, I'm going to let R equal 1.454545. I see in this one again that two places repeat. The two digits, 45, 45, 45, two digits repeat. So I'm going to multiply again by 100 on both sides because of the two digits. So 100R would equal, move it over two places, 145.454545, ... which means it continues. Remember, R equals 1.454545. So if I got ready to subtract those, this would be 99R, and all this decimal part would subtract out, and 145 minus 1 would be 144. I could divide both sides by 99, and R would equal 144 over 99. Now most of the time that is your answer, but in this one unfortunately it's going to reduce. So it's going to reduce. And actually it reduces by 9. So the bottom's pretty easy. 99 divided by 9 would be 11. But the top one we might need a little bit more help with. So 9 goes into 14. And 9 goes into 54. So it would be 16 over 11. And that's how it would look. And that's how you write a repeating decimal as a fraction.